And now we are going to do a matrix equation.
Binnacle project.
Hi, this is Fernando. Welcome to my channel. I want to tell you that you must feel very proud being here because when you are trying to solve a matrix equation, it means that you have already mastered the basic operation with matrices. So let's read the statement and let's try to solve it. Well, let's begin. We are asked to calculate this equation. We have to solve it for x. A squared, matrix A, you can see there, 1, 2, negative 1, 1, times matrix x plus b times b multiplying matrix x again equals c. Well, look carefully at the equation and you can see that, luckily, we have our matrix x on the same side, the right side in both terms. Why is it so important? Because now we can take it common factor to the right. Look, a squared plus b multiplying our matrix x equals c. And it is very important to consider that because, as you know, in this topic, in algebra of matrices, doesn't exist the old commutative property. So that's why we have considered to take x common factor to the right. Now what are we going to do? Well, let me call this parenthesis matrix D. Now I'm going to calculate it. We are going to do a squared, as you already know how to square matrices, plus b. So the structure that we have is D multiplying matrix x equals D. Once we have our matrix D, what are we going to do? Can you see that matrix D is at the left side of our matrix X? So let's multiply both sides of our equations by the inverse of D times X equals the inverse of D times C. And why are we doing it? Because you already know that a matrix multiplied by its inverse is equal to the identity matrix. And what does it mean? That the identity matrix multiplying x equals x. And there you have our matrix solved. We are going to do, first we are going to calculate matrix D. Then we are going to calculate its inverse. And we are multiplying the result by matrix C. And that's it. Now let's begin to calculate our matrix D. It's equal to a squared plus b. So let's bring matrix A in order to square it. A squared is equal to matrix A is 1, 2, negative 1, 1. And as you probably know, it is forbidden to square these 4 positions. No, the way to calculate the square of a matrix is multiplying the matrix by itself as many times as the exponent indicate, in this case 2 times. Now we are going to calculate our result. You already know that when you are multiplying 2 matrices of order 2, the result will already be an order 2 matrix. So, first position, row 1, column 1. 1 times 1 is 1. 2 times negative 1 is negative 2. 1 minus 2 is negative 1. Second position, row 1, column 2. Row 1, column 2. 1 times 2 is 2. 2 times 1 is 2. 2 plus 2 is 4. Now, row 2, column 1. Row 2, column 1. Negative 1 times 1 is negative 1. 1 times negative 1 is also negative 1. Negative 1 minus 1 is negative 2. And finally, row 2, column 2. This is negative 2. and this is 1. Negative 2 plus 1 is negative 1. Okay? So now it's time to put it there. Negative 1, 4, negative 2, negative 1, plus matrix B that you can read that it's 1, 2, 0, 1. And there we have our matrix D in order to solve our matrix X. Negative 1 plus 1 is 0. 4 plus 2 is 6. Negative 2 plus 0 is negative 2. And finally, negative 1 plus 1 is 0. This is matrix D, and now we are going to calculate its inverse because it is what we need. Let's announce that we are calculating the inverse of D using this formula. The adjugate of D transposed divided by the determinant of D. Okay? I'm beginning with the determinant of D because 0, 6, negative 2, 0. Not only because we need the result, but because if this determinant equals 0, it would mean that matrix D doesn't have inverse. We would stop the video and goodbye. But if it is not 0, we can calculate the inverse of D. And of course, this determinant 0 minus negative 12 is 12. So let's go on. Now we're calculating the adjugate matrix of D, and you probably know that it will be also an order 2 matrix and position 1, 1. Let's remove row 1 and column 1. Row 1 and column 1. Can you see this 0? This is the result for the first position. Okay? Second position, row 1, column 2. Let's remove row 1 and column 2. Negative 2. Third position, row 2, column 1. Let's remove row 2 and column 1. Can you see this 6? And finally, row 2, column 2. Let's remove row 2 and column 2, and this 0 is the result for this position. As always, do you think that these are the adjugates of our matrix D? Of course not. These are the complementary minors. To become these complementary minors into the adjugates, we have to use the snake, okay? Positive, negative, positive, negative. Please move like a snake. Positive, we won't change the sign, but if we say negative, we will change it, okay? Positive, negative, positive, and negative. That's it. Now it's time to write the solution. Let's transpose. It is very important. Don't forget to transpose this matrix. 0, 2, the first row, but turn it in form of column. 0, 2. And negative 6, 0, but in column. Negative 6, 0. Divided by 12, the determinant. And it's time to consider if we should divide these 4 positions by 12. And well, let's do it because, 0 divided by 12, 0. Negative 6 divided by 12 is negative 1/2. 2 divided by 12 is 1/6. And 0 divided by 12 is also 0. It is not very ugly, so we can put it this way. Once we already have the inverse of D, let's write the solution because it will be the inverse of D. Here you have it. 0, negative 1/2, 1/6, 0. Multiplying matrix C, that you can read it from the statement. 0, 12, -2, -4. And here is the solution of this exercise. Here is the value of our matrix X. It will be, of course, an order 2 matrix. And the first position is row 1, column 1, 0 times 0, 0, plus 1. 1/2 times 2 is 1. Second position, row 1, column 2, 0 times 12 is 0. And -1/2 times -4 is plus 2. Third position, row 2, column 1, row 2, column 1, 0 and 0, 0. And row 2, column 2, 1/6 times 12 is 2. And 0, 2. This is the solution of our matrix equation. If you came directly from the statement at the beginning of this video, I hope you got it right. And if you came with me, hope you have understood the setting and the solution of this matrix equation. See you next time. And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!